So today our topic is about randomness in simulation and games. So the first question is about what does randomness mean? So from the textbook and also from the online session, we know randomness is about random. So something is random and lack of patterns in terms of unpredictability. So we know random are things that are unpredictable. And the usual criteria for determining randomness is to avoid any repeatable and predictable events or results. Another word to define the randomness is randomness only exists in context as a relative property of the sequence of numbers. So you cannot just say the single number is a random. We need to consider in the connection of the numbers or the number site. So in terms of randomness, we need to consider in large connection. It's just how we did for the simulation, right? For the input data, we need to make the data set as big as we can, because that will make our data set more reliable, I would say. So another to describe the randomness is the possibility of this event. The possibility of this event is uniform distribute. What that means? It means that, for example, the outcome of what happened when a dice is rolled, because the dice will have 6 sides, and the result is not predictable, right? So because the probability of each of the number is 1 to 6, they are the same possibilities. And how utilize randomness in simulation games, and what's the difference? Both of them are using randomness to simulate reality for two main purposes. One is to manipulate the abstraction of the object, and another is to represent the complex process. Because more randomness we offer, we can using the randomness to present or the modeling more complex system. And also we enforce the abstraction, which means we make our simulation or game more real, more close to real, right? Real world. Because in the real world, most of things are unpredictable. That's the nature. So that's to say, it is not essential to the simulation, but that lends a sense of reality, complexity, or presence. And in simulation, we'll be generating random events and random data set to present like timeline or other properties. For example, considering we are waiting for the line for the bus, right? The passenger arrival at the bus stop, this event, or wait for the arrival of the bus and the bus arrival time, and so on. Those events are the random event. And in terms of game, there are basically two types of randomness in game: the input randomness and the output randomness. The first type is referred to something random happen before the player has some input. Before player do any actions or trigger anything, like the players try to click the mouse or move the joystick or do something. There will be some random already defined. For example, like the levels of the game, like level 1, level 2, the difficulty, they are all random generated without player input. Another type is the output. So this time is more about the user decision. they need to decide or take action, and the game will be figure out what happened based on the user decision, because each player may have different reaction. So that's some randomness in the game, because that will make the game more real, more fun, I would say, because most of players, they want to challenge themselves, right? In terms of the randomness, you can make the game more real and have more challenge, and also have more features to play. For example, in FPS game, like first-person shooter game, how good you control the spray recoil depends how good you are at the game. Because when you shoot the enemy, you need to control your bullets. They all have some patterns for the spray, but how good you are at is depends on how did you control that spray pattern. That's my understanding, especially for the FPS game. So last question is about what is the role of time in anchoring events in simulation. So the time is the core of everything that happened, because the time is a indefinite continued progress of the existence and events. We use time to sequence events, to make it at some order, like today, tomorrow, or yesterday. We are using time to measure it. So, and also all simulations are anchored by time. Moreover, if we want our simulation to be more accurate, then we need to do same things in the same order and for the same amount of time compared to the reality. For example, in the traffic simulation, right, we may able to speed cars up and slow them down to change some properties like the speed or the distance. That will all refer back to the changes to the time. That's all about those changes. It's about time changes. So the time measurements are connected for the non-time, and a reliable estimate of average can be calculated. So in most simulations, we all refer to the time. Time is a pretty key or core aspect of everything, because you want to things in such order. Then you need to consider in time. And what does the addition of randomness to event mean for the whole simulation process? My understanding is those four perspectives. The first one is the accuracy. Since, like I mentioned before, if we want to make our simulation more accurate, we need to add a randomness, like the randomness for the input data, or some randomness events inside the system, because the reality, the real life is in random nature. Even though the original system, there will be some events will be random. And a second one is for the complexity. More randomness you add to your system is a way to represent the complex scenario or complex system. And the next one is the quality for your outcome, because if you can make sure your input data is no bias, your input data is reliable, you want to add some randomness to your data, because you don't want people think you intend to make those data to get some desired outcome. So which means in simulation, if we want to have more confidence on our outcome, we would better give random data and also perform the entire process in a random fashion. And the last one is the measurement, because from the the way to determine the quality of your simulation and the reliable or robust of your simulation is a way to check the randomness, how much randomness you have in your system. That's my understanding for that. So back to my project. How will randomness be defined and what values will be generated? So in my project, I was trying to simulate a new student orientation ceremony. It's more about to come up with a better resource management plan with a lower cost, without any waste, and make the entire ceremony more smoothly and just come up with a good plan. So for the simulation, right, when selecting from the range of values of simulation process, we want to select the selection to be made randomly in order to avoid introduce any bias in the input data. That's enforced the input data. So the randomness I will definitely take care for my input data. And also the system simulation rely upon the random number selection to achieve this reliable input data. That's how we do. And what's the value I will be generated? So in my system, there will be a lot of properties at random. For example, like aperture or arrival departure time as per each student. It will be random. And also the check-in time, the height of the student, some other characteristics, and also the total number, the number of gate, or some number of staff, and other resource. Those properties we can easily manage. We can assign random data to those properties. That's those randomness in my system. We may have more randomness values, but we'll see. Because what I believe, the more the degree of the randomness determines the quality of your system, the simulation. I may using some website or the computer programs to generate those random data set. We know we have idea about pseudo random, but most of in the computer programs, they are the pseudo random generated numbers. Yeah, I think that's it. Thank you.